Hey everyone, and welcome to this explainer. Today, we're diving into what is essentially the ultimate security detail for our most valuable assets in the age of artificial intelligence. We are unpacking the ISO/IEC 42001 2023 standard. Think of this international framework as a comprehensive playbook, one that's specifically designed to guide organizations in securely managing and protecting AI systems throughout their entire lifecycle. And that really brings us to the central question we all have to ask ourselves right now. How do we actually trust AI with our most sensitive secrets? I mean, AI is revolutionizing everything: healthcare, finance, logistics, you name it. But to do that, it relies on massive, explosively growing datasets. If that data is left unprotected, the consequences of a breach or deploying an algorithm trained on compromised data are frankly terrifying. We desperately need a secure way to ensure these systems are accountable, transparent, and above all, safe. So here's our roadmap for today's journey. First, the AI data challenge. Second, core data protection principles. Third, a risk-based approach. Fourth, applying protection measures. And finally, securing AI data integrity. All right, let's jump right into part one, the AI data challenge. To really wrap our heads around how this standard works, we're going to follow a highly valuable VIP through its perilous chronological journey inside an AI system. Now, ISO/IEC 42001 aligns perfectly with global privacy laws by defining personal data as any information relating to an identified or identifiable natural person. That is our VIP. We're talking about a name, contact details, medical history, or financial records. And when you're dealing with highly sensitive data like that, our VIP absolutely requires an elite level of protection. Because here's the core challenge. AI systems are incredibly data hungry. They depend entirely on the information we feed into them. Notice the direct cause and effect here. If our VIP is left vulnerable and the data fed into the system is either incomplete or unprotected, the AI's outcomes are going to be inaccurate, unfair, or even discriminatory. A data breach is obviously one massive risk, but a flawed algorithm churning out skewed outcomes is another huge one. And that is exactly why a rigorous, secure framework is absolutely essential before we even think about flipping the switch on an AI system. Moving on to Section 2, Core Data Protection Principles. So, the ISO standard lays down these absolute core guidelines for data processing. Think of them as the ground rules. First up is data minimization. We have to strictly restrict what data the AI collects to only what is absolutely necessary for that specific purpose. No hoarding excessive information. Second, storage limitation. We firmly limit how long our VIP gets to stay. You define a specific retention period, and when that data is no longer needed, it is securely deleted. Third is integrity and confidentiality, which just means the data has to be processed securely to protect against any unauthorized access or loss. And finally, transparency. Organizations must thoroughly document these processing activities so they can be audited. You basically need to know exactly where your VIP is and why they're there at all times. Which brings us to Section 3, a risk-based approach. The standard brilliantly outlines 4 chronological stages of a risk assessment process, which really helps break down these massive organizational challenges. First is identification. You have to recognize potential threats right off the bat, like maybe an employee accessing sensitive customer data without authorization. Second is assessment. Evaluate the likelihood and the actual impact of that specific risk. Third is treatment. Implement strict controls to reduce that risk to an acceptable level. And fourth is monitoring. You have to continually review the effectiveness of those measures because AI risk is definitely not static. It evolves dynamically every single day. Okay, part 4, applying protection measures. Now, the standard highlights several technical techniques to literally armor our data, and it is absolutely crucial to understand the difference between these two. Anonymization permanently strips away identifying information. It is gone forever, it cannot be undone. Pseudonymization, however, replaces that identifying information with a placeholder that actually can be reversed, but only under highly specific secure circumstances. So for example, a healthcare provider might pseudonymize patient diagnostic data when they're running medical research with AI. The researchers get to analyze the trends without exposing individual identities, but the healthcare provider can still reverse that placeholder if, say, a critical health issue is discovered for a specific patient. It really acts as a brilliant protective shield. Let's actually map this out practically. The standard requires that the treatments we choose are appropriate and effective for the threat. If the risk is data interception while our VIP is moving through the network, the treatment is robust TLS or SSL encryption. If the risk is unauthorized access, the standard dictates strong access controls, like multi-factor authentication.
And if the risk is biased decision-making, let's say in a hiring algorithm, the treatment involves rigorous algorithmic fairness audits. This framework basically acts as a customized, highly technical shield for whatever specific risk the AI system happens to present.
And finally, Section 5, Securing AI Data Integrity. So what exactly is data integrity? Well, according to the standard, data integrity means ensuring that AI data is absolutely not tampered with or altered in any way during its storage, transmission, or processing. In an AI-driven environment, this is make or break. If the data fed into an AI system is corrupted, tampered with, or just inaccurate, the AI simply cannot produce reliable, ethical outcomes. We all know the old adage, garbage in, garbage out. But when we're talking about AI, garbage out can mean devastating real-world consequences for real people. To actually maintain this integrity, ISO/IICA 4201 gives us a few specific powerful tools. First, we use data provenance to rigorously track the origin and the entire history of the data as it flows through the system. Second, we use data validation, putting automated checks in place to catch any anomalies way before the data is ever processed. And third, we use strict audit trails to maintain chronological logs of exactly who accessed the data and what they did with it. Think about a massive financial institution using AI for credit scoring. By tracking the data's history and validating the inputs, the institution successfully prevents disastrously skewed outcomes that could result from manipulated historical data. To wrap all of this up, the big takeaway here is continuous vigilance. Accountability is paramount. Organizations have to designate crystal clear lines of responsibility for their AI decisions. By documenting and continuously improving these structured practices, organizations don't just stay secure, they prove their compliance with major global privacy laws like the GDPR. They build unshakable trust by demonstrating that their AI data lifecycle is thoroughly and relentlessly protected. Which really leaves us with this final thought to ponder. The AI landscape is shifting literally every single day, bringing us incredible innovation but also totally unprecedented risks. Implementing a structured, secure governance framework isn't just a box-checking exercise to avoid fines. It's about fundamentally protecting the data lifecycle at every single step. So, as AI continues to evolve, is your organization ready to protect the VIPs of the future? Thank you so much for joining me for this explainer. I hope this gives you a powerful understanding of exactly how we can secure the AI lifecycle.